Hi guys, today we will talk about Keras data augmentation. So here we have two tasks L1 and L2 regularization. In this task we analyze and compare the impact of L1 and L2 regularization on model performance and weight behavior using synthetic regression data. Then we'll do test setup. So first we'll import all the required libraries, then generate synthetic data, build and train models, and we'll do visualization. So as you can see, we have visualization of training loss comparison, an override versus L1 versus L2. Then we'll select dataset model with and without dropout. We'll plot the graph again of dropout regularization, validation, loss comparison. Then we will build a simple model and again do visualization effect of early stopping and validation loss. Then we'll make a class named MC dropout model. We'll train the model, predict with dropout, and visualize again. We'll visualize the Monte Carlo dropout predictions with uncertainty. Then we'll build models with different initializations. We'll again do visualization. So effect of different initializations on training loss. Then models with and without batch normalization will occur to visualization by PLT.show. So this visualization is of effect of batch normalization on validation loss. Then we'll go to custom dropout layer, custom regularizer, model using custom layers, and then again visualize the graph, custom regularization and dropout validation loss. Then we'll define block directory, TensorFlow callbacks model for training and train with callbacks. This is the TensorFlow view. As you can see, time series, scalar, graphs, everything is there in this. Distributions, histograms, everything is there in this. Epoch learning, everything. Then again, we'll install Keras tuner and we'll define a function named build model instantiate unit plot predictions, best model prediction tuned by Keras tuner, and then again we'll install Keras CV. We'll load small data set, preprocess plus resize, apply Keras CV augmentations, visualize augmentations. So this is the visualization. As you can see, different images of top, original, and augmented. And then we'll install Ogly. Um, Python 3 Magic will import all the required libraries and prompt and load. We will upload an image of, let's say, a dog or anything else, whichever you want to upload. And we can see different type of images, image display here, two dogs and different brightness, then low brightness, contrast, flip, then grayscale, degrading image pixels, skew. Then again we'll install Fastbook. We'll load and resize the images, convert tensors and normalize display images. As you can see, these are all the images. Now we will move on to advanced Keras deep learning constructs concepts. First, we'll start with importing all the libraries. We'll make a class, one cycle scheduler, visualize learning rate. So one cycle learning rate schedule, then a custom robot layer, import all the libraries, visual test of dropout impact. So as you can see, distribution before and after MC alpha dropout, and then we will custom normalization layer. Import all the libraries, make class, example usage, output shape is 1016, then tensor board for training visualization, import all the libraries, define a simple model setup, train. Then as you can see, again we can see tensor board, histogram, epoch learning rate, everything, scalars, graphs, distributions, histograms, everything is uh, displayed here. Then task 5 is custom loss function. Upper loss. So what is upper loss? For small errors it behaves like MSC. For large errors it behaves like ME controlled by permitted data. Now first we import library, make a class, visualize the behavior. This is the behavior of upper loss versus Uber or whatever it is, versus error. And then task 6, custom activation, initializer, regularizer, constraint. Then we'll import library, custom activation, custom initializer, custom regularizer, apply to layer, forward pass through. Then task 7 is custom metric. Your metric will make a class example usage. Uh, Task 8 is custom layer exponential layer guidance and Gaussian noise layer normalization. We'll make a class expand layer Gaussian noise custom layer normalization visualize the effect of add Gaussian noise layer. Then task 9 is residual block residual regressor. So we'll make a class visualize the forward pass. Then my momentum optimizer, import all the libraries, test the custom optimizer, we will minimize it, and custom training loop on fashion amnest. So in that import library, load the preprocess, load and preprocess data set, normalize it, build it, and define a simple model, define loss function metrics, visualize it and plot the graph. So this is the graph of it, training loss over epochs and training accuracy over epochs. So these were advanced Keras SM at 6. Thank you so much for watching.